Well, the last time you were here, I think what you saw was a piece of wallpaper and a set of forks.
I am the engine in this vehicle.
So, you can see I've moved on a bit. Well, the design came about because I thought to myself, right, okay, this is not about human rules anymore, this is about the laws of physics, the only constraining factor. Apart, obviously the rules are, got the flat road, no assistance, no downhill run, no wind assistance. So basically a human being has to use its energy in real time to fly across a road through the atmosphere. So I thought, okay, what limitations of possibility? What's that total, what's the edge of the cage of possibility? So thinking about the laws of physics, the number one thing is aerodynamic resistance. That's the overwhelmingly 90+% of the energy used to do this is aerodynamic resistance. Has thought, okay, so how do I minimise aerodynamic resistance? So thought, okay, what's the given, the unchangeable, immutable, the immutable minimum that you have to endure as a resistance? And that's a human body. The only part of this that's not changeable or adaptable or you can't innovate is a human body. There's a choice. You can either go head first or head behind. Now, if you actually analyse it in terms of the width of the shoulders, even just squish them down, the width of the shoulders is the widest part of the body. So if you take it scientifically, that the most aerodynamic shape for anything is a teardrop shape. That's a known. So you want to start from wide, not so wide, which is the hips. That's a limiting factor. You can't, unless you're going to get surgery, you can't limit your size of your hips. They are what they are. But it's narrower, it's slightly narrower on your shoulders. If you take your feet together, if they're moving but just missing each other, then they're considerably narrower than your hips. So what you've got is shoulders, hips, feet, which tail down into a teardrop shape. Then, so obviously head first is the way to go. My whole concept has been from the early 90s, building bikes is, this is me and a bike as one unit. Like taking the holistic approach, because even the world of cycling, mainstream cycling, the whole attitude was, right, how can I make that bike faster? And then the rider gets on it and adjust it to what feels good. Whereas I moved towards the holistic approach of, it's bike and rider as one unit. How can that unit go faster? This is more intimate in terms of you've got your hip support, you've got your shoulder support. There's so much more contact with this machine than what there is with a regular bike, and it's so much more crucial. This is my hip support, which is built exactly to my hip width. That point there is basically supporting my hip bones on there. So it's actually surprisingly comfortable because of the amount of surface I've got. The good thing is, I've actually got the blueprint right here. Like I've got the advantage that other engineers don't have, because normally what happens in these situations is the engineer goes and builds the best bike and goes, right, who can we get as an engine? So they're forced generally, not always, but generally, the engineers that build these bikes are forced to have a bike that is generally going to fit most riders of a certain size. Whereas I've got the advantage to go, right, I'll measure that against my hips. Well, hold on, that needs to be a centimetre narrower, and I change it in real time for me. Either you compromise that it fits kind of anybody, or you go, you know what, this bike's made for me and just me ergonomically to fit my shoulders, my hips, everything. Because as soon as you make something universal, then you're giving away percentages of perfection. Making something just a perfect fit is perfection for my body. I tell you what I need. See your standard 653 old style Reynolds head lugs. If I have two of those, yeah, that'd be fine. I think other people have thought about this, but once you deviate from what the norm is, then it becomes incredibly difficult to build anything. For example, all the components I've had to build here in terms of what I'm building, I've used bike components when I can, but the entire frame from start to finish is completely new in terms of where everything's going. So what you've got is an uphill struggle in terms of you're at the cutting edge. Whereas if you copy what other people have done, which is a recumbent bike, you can buy components for recumbents, you can buy bucket seats, you can buy, you got the design and you know what head angles you're using, you know what the frame angles are, and you've got all these components that you build up your recumbent. Whereas I don't have that luxury because I'm going from a thing that's brand new, it's cutting edge. So I think a lot of people have seen the success of the world record on that designer bike. I think, okay, I'll use that designer bike, try and do it that wee bit better, maybe a bit lighter, a bit narrower, whatever they can do to try and improve it in some way. I also built this. That's your Reynolds fork blade, curved. And ta-da! Piece of saucepan. Yeah, there was a saucepan. That was when I got down to the curvature of my shoulders, built exactly where that's to go with that and the curvature of it. At that point, I knew I had to either use carbon or glass fibre or aluminium or some surface that's going to provide a flat, smooth surface onto my arms. And I thought, well, actually, the perfect thing would be a piece of stainless steel, which would be relatively light and accessible, and probably actually end up lighter because if you use aluminium, you've got to have to bolt that onto the steel. You can't weld aluminium to steel. Now, if you use glass fibre, then you've got to use an awful lot of it so that it's not actually going to give way at some point. And you've got to join it to the steel. So the actual joining process and the strengthening process probably ends up a heavier and a longer time, more time-consuming thing. And I thought, you know what, there's an old saucepan under my kitchen. I thought, old saucepan, cut the side out of it, and it's already got a curve on it. Wee bit more curve, squished it about a bit, and stainless silvered straight onto that material to form shoulder mounts. And you know what, the whole job, once I thought, hold on, sacrifice a saucepan, the whole job from that point, shaping and silver soldering, took about 2 hours. There was no going anywhere out to search for glass fibre or getting an engineer, can you make that component for me? It was like saucepan to shoulder support in 2 hours without leaving my kitchen. Well, I need to finish this component and have it in situ as a perfect piece of engineering. Well, a good enough piece of engineering. There's never perfect engineering. But what I do need to do is manufacture the power output unit. I need to measure. This has to be finished so I can measure the furthest point of my power output. I think the point I'm actually going to enjoy actually having it finished. I mean, it's great as a work of art, and it's nice to mess about your kitchen with stuff. But there's quite a volume of it. And ultimately, it's a cycle, so I want to go, there, fitted the last cable, right, kit on, I'm going to go and ride this.